Get hyped up. Let's go get hyped up. Hello, my name is Brian, and I'm here to hack on some Tiger Beetle stuff in Rust. So Tiger Beetle is a financial database written in Zig. It's very high performance, but we are working on a Rust client for Tiger Beetle, and we're doing that work in Zig. So we're doing that work in Rust, not Zig. If you're here for Zig, I'm doing Rust. But this project is to create a, excuse me, a client for Tiger Beetle for use in Rust programs. Tiger Beetle already has clients for Java, JavaScript, Go, and Python. And we're doing the Rust client. All these clients are bindings to an underlying library called TB client, which is written in Zig and presents a CFFI. So our task for this project is to just create idiomatic REST API on top of the Zig library that does all the actual work. Sorry, I'm burping so much. Let's see, we've been doing this for a month and a half or more. I don't know exactly, quite a number of streams. And we're doing the whole project on stream, front to back. So if you watch from front to back, this should all add up to like a complete production quality Rust project that has, a lot of interesting Rusty type of subjects, FFIs, async programming, testing, verification, deployment to crates.io, all the standard Rust stuff. It's kind of like a bread and butter Rust type of project right here. And recently what we've been doing is kind of understanding how Tiger Beetle requests work and how best to model them in a asynchronous Rust API. And we've got a pattern going within our Rust library that looks, very good, and it's kind of easy to replicate for more requests. So far we've implemented 3 requests, and we're kind of in a slog right now where our task going forward is just to implement more requests. So we're just kind of taking the work we've already done and just saying, all right, let's do this one more time, but for another type of request that is slightly different, but mostly the same. We've done 3 requests, as I said, and I think we've got 8, 9 total to finish. So this stream and the next stream is going to be pretty straightforward and chill. Not super taxing, hopefully. But we need to just kind of get it done. This is kind of taking a long time. Doing all this stuff on stream. It's taking a while. But we got to kind of push through all these remaining requests so we can get to more interesting problems. So today we're just going to implement another request. Easy peasy. Let's see. Everything is looking good over here, I think. Let me check all my stream and stuff real quick, chat. All right, I think it's okay. And let's go check out our code. So this is our Rust client workspace, and my history is just garbage right now. And the first thing I usually do when I start over, sit down and work on a project again, is just kind of catch up to where I was and remember what was going on last time. And it's only been a few days now, but I'm just going to go ahead and make sure that we have the C library built, which is, the C library is not, the build systems are not tied to each other right now. I don't have the Rust build and the C build or the Zig build working together. So I just always want to make sure the C library, C/Zig library is built and ready to go. And you can see it did a rebuild there. I still don't really understand why it's deciding to rebuild. I don't think I've made any code changes to the Zig code. And here's our Rust library. I'm just going to check that and build that. Pretty much every time I sit down, I want to prime my Rust workspace to make sure all the dependencies are type checked and built. And we're just going to get right to it. This is my list here of what we've done so far. Eventually, I'm going to upload all these episodes to YouTube and put them all into a playlist, so you can watch them all and back to back. Should be good for like going to sleep or something, or try to make the streams pretty chill. But I'm keeping a list of like everything we've done here for future reference when I make that playlist. So here's our code again, and let's just walk through it real quick, just as a refresher. During development, I'm allowing unused variables in Rust. So if we take this off, we'll probably see some errors. Here's our imports. These are the generated Rust bindings to the C library tbclient. And we can go look at tbclient.rs. This is that module, tbclient. Generated by Rust bindgen from the C headers, which are also generated by the Zig build. I'm renaming this import because I'm going to use the things in this module over and over. And so I want to use this, tiny little namespace to identify all the things from the bindings module. I was wondering about this. So last time, this project involves a lot of like type conversions from Rust types to C types that are almost identical types. Just one looks like Rust, one looks like C. And they were getting pretty ugly. I just don't want to look at them when I'm reading through all of our code. And so I created a module called conversions. We did this last time, probably the last thing we did before we took a break. And this is just implementations of from the main Rust conversion trait for infallible conversions. And you can see this is not interesting code at all. It's all boilerplate. You could imagine a machine generating this code like the bindings themselves are generated. But also, this is not too bad to write by hand. It's kind of like on the borderline, right? I can write this by hand pretty fast, and a lot of these streams we're doing right now are me just typing all this up, just doing data entry. But we could also, create maybe a custom code generator to generate this code just the way we want. Or maybe there's even an off-the-shelf generator that can make these implementations while preserving the Rust API that I want. The reason we're doing this and not using just the bindgen generated APIs is because if you look at something like tbclient T, where is it? Not tbclient T, tbaccount T, you can see this generated code, looks reasonable, but it looks like C code. And even if we kind of type def this away and say like, give it a better Rust name as a type alias, the C-ness will still leak into the public API. And I want the API to look very pristine, be very easy to read and document. So we're kind of handwriting a layer of, I'll show you over here. This is the corresponding Rust API type, just kind of handwriting this layer of Rust types on top of the C types, just to make it, perfectly beautiful. And this conversions module is going to accumulate a lot of boilerplate, just handwritten boilerplate, which is very error prone, as we've discussed a few times. But eventually we're going to write some unit tests that just guarantee that all these conversion functions always stay exactly correct. Hey, Chad, I see you. Hey, Cargo Moon, good to see you again. You've been seeing a lot of these streams. I'm grateful you keep coming back for more. Hey, Panda Kenji94. I'm glad to see people showing up today. This project has a GitHub repo, as you're asking in chat. So the main repo here is the Tiger Beetle repo, which is GitHub/Tiger Beetle. And that's the main database. But this Rust bindings is not yet on the main branch yet. And let me go to the browser real quick here. I'll go find where my branch is. So GitHub Tiger Beetle. This is the main Tiger Beetle repo. Pretty much everything in Tiger Beetle is in this repo. My branch, my fork is Burson/Tiger Beetle. My name is Burson on GitHub and on some other places. If you go to my GitHub IO page, there's links to some of my other stuff. So this is my fork of Tiger Beetle, and the branch I'm working on is called Rust Client. So if you want to go check this out, and again, my commit history is garbage right now. I'm going to clean up my commit history before we PR. But this is my branch. And I'm going to submit a PR pretty soon. We're kind of getting to the point where we can say that we have like a prototype level thing here that somebody could reasonably try out. if they're desperate or if they want to help out. So kind of once we've gotten all of these requests implemented and kind of we're in the slog of implementing all the requests, once I've got the requests implemented and the API looks reasonable, I'll probably tie the build system together so that the Zig build runs the Rust build and or vice versa, and then submit a PR for people to start looking at. But it won't really be production ready. But then at that point, it'll all be entry, and people can just find this project in the main branch of Tiger Beetle. So again, what were we doing? Let's pop the stack here a few levels. I was just kind of going over where we were here. This is the type that the library defines, the client. So we looked at the conversions. This is the client. The client is almost exclusively concerned with submitting requests to the underlying client library. We can have a constructor here that's pretty simple. Some of the things here are kind of stubbed out. There might be more to do with the constructor, but it's good enough for now. And then we just have our requests. And all these requests are going to follow the same pattern. So here you can see submit create account here. And these are all just, much of what we've done for weeks is just kind of develop like the smallest pattern possible here for implementing more and more requests. And now we are reaping what we've sown and implementing these requests by kind of copying, pasting this 20, 30 lines of code and slightly modifying it. You can see we've got submit create account, submit create transfer, submit account lookup. Today we'll probably do submit transfer lookup. And then we have a little destructor here that kind of works, but is probably not fully production ready. There's probably more we should do here on close, like make sure that all the outstanding requests have completed before you finish closing asynchronously. And these request types, they, thank you, Cargo Moon. Let's see, how much did I screw up here? This is a problem I've got. I've been getting better at it, but I often forget to switch OBS scenes to show you the things that I'm talking about. Thanks, Cargo Moon, for helping me out and reminding me. Library, right? So I didn't miss much here, but we have the constructor and then all these request methods. And these all follow the same pattern. It's just a small amount of code that needs to be minorly tweaked to implement more requests. The big part of implementing these requests is actually defining any new structs. And these are mostly mirrors, like these are mirrors of structs that are already in the C library. And then these are kind of ugly mirrors of what's in the C library. They're not quite the same, but they're similar. And then all those conversions I showed you. That's the big part of implementing each request. And then down here, to support this pattern for requests, we've implemented two little helper functions that are highly generic, create packet and collect results. And a big part of what we've done is figure out how to make these generic functions. So we first implemented them in the individual requests, duplicating the code, and then we extracted them out and made them generic. Very common refactoring pattern. And this create packet, looks pretty comprehensible. And this is all, what this does is creates a packet, which is the unit of execution we send to the client library, which then translates it and send it to the server. And then we submitted that packet, or we just created the packet, and then the method itself submits the packet. Then the other one is just what you do once you've received the result of the packet. And this is a very complicated method signature. This makes me sad to look at, and I kind of feel like I need to continually apologize for it on stream, but it does the thing that it's meant to do. And if you read it carefully, you can understand it. Pretty advanced, though. Okay, let's get going. That's enough recap. Time to stop procrastinating and write some code. All right, so each one of these request types has an input type and an output type. The input type is called an operation, perhaps, or maybe a request. There's several interrelated names in Tiger Beetle, and the output type is the result type. Each of these methods handles multiple events at a time. So you can see here we have an array of events, and the output is a vector of results. So they correspond one-to-one, input and output. And we're going to do submit submit transfer lookup today. And I'm going to go put submit account lookup over here on the right-hand side of the screen. So I can crib off that while I'm doing the new function. I'm just going to copy the method signature and stub it out. Now, a big part of, I'm going to put an async to do here. This method returns a future, so anything it returns has to be async. And this will just allow it to type check without actually filling out the body. So a big part of creating each of these request types is figuring out what the input type and figuring out what the output type is. And we can consult the state machine in Zig to figure that out. This is the core data structure in Zig, in Tiger Beetle. And these are the for each operation. This method defines the event types. This method defines the result types. But I already know that for submit transfer lookup, the event type is probably going to be a transfer ID, and IDs in Tiger Beetle are U128s. I can see right here on the right-hand side, lookup transfers is a U128 input event. And then the result type, I'm going to have to go define something for it, following the pattern that I've established. So here the old account lookup was account lookup OK result type. We're going to call that a transfer lookup OK. And we're just going to go search for our transfer lookup OK, account lookup OK type. And we're going to kind of crib off this and make a new one for transfers. So we're going to keep these in roughly the same order that the Zig code tends to define them. So I'm going to put these after the other definitions and call this transfer lookup OK. And this is probably going to return a transfer, I'm assuming. If you look up a transfer and it's found, you're probably going to get a transfer. And this also means I'm going to need to define a transfer type. So I'm going to go search for the account type. And again, this lookup transfers and lookup accounts, they both follow similar patterns. So I'm just kind of making an educated guess of what I need to do here. Oh, I already have a transfer defined. Of course, we already did create transfer, which sends transfers, and now we're doing lookup transfer, which receives transfers. So we already have transfer defined. So I think I've stubbed out enough here that this should type check. So we're going to run, let me go back to my code real quick and give it a once over. Yeah, this looks like it's complete. So I'm going to run cargo check. And it did a check successfully. I'm going to checkpoint my work. And again, I'm going to go back to put on the right-hand pane my reference code, which is submit account lookup. And I'm just going to start copying and pasting from this method into my new method. This should go pretty fast, actually. I need to, especially if I don't like stop and chit-chat about conversion functions. So if I power through those conversion functions, we should get this done pretty fast. All right, so now we got to kind of pour over this code with like really careful eyes and make sure all the types are replaced with from the account lookup types to the transfer lookup types. In this create packet, these two types probably don't need a change. One thing I'm noticing here is that like I can't tell from reading the caller side here what these types represent, but I'm guessing this is the input type and this is the Rust input type, and this is the C input type. And then in the case of submit transfer lookup, they're the same type. They're just U128s. In other cases, there has to be a conversion step from the surface level Rust API to the internal C API types. And these are going to be 128. Now we have to make sure we put the right operation here. And this is like, with the pattern we've established here, this is like the one place where you can really create an error in this code, because this isn't type safe. This is just a U8. So I could put the wrong operation type in this call, and the underlying C code would just scribble all over the place because I'm passing in the wrong types for the operation. So got to get this right. You know, most of these other types are just type generic. So if you, or most of these other changes here are just type generic. So if you get the types wrong, it's just not going to compile. But this is not type generic. It's just a value we're passing into this function. Anyway, lookup transfers. Just going to guess that is probably the name of that value. This doesn't have to change at all. Here we're waiting on the result from the other thread. TB client is multi-threaded. And then we're going to collect results. And this is also, no, I think this is all pretty type safe here. So here we have to say, we have to do a little comparison. This comparison is like telling us like whether the result we've received correlates to an input we've sent in order for the interpretation of the results to work correctly. So this is probably the event type, the C event type, which is a U128 in our case. And this is probably the result type. See, it's called next result. And I'm guessing this is going to be a transfer T, just based on the pattern. And this should be the same thing. We're just comparing the ID of the transfer to the ID we're looking up. Obviously, we're doing a lookup requests. And then these two should be the same. So this case is like a sentinel value to return if the server didn't return any results. The Tiger Beetle server tries to return no result for efficiency. So if it doesn't return a result for a request, we know that it means not found in this case. If it does return a request, this is a higher order function here. It looks like a variant, but it's actually a function that will create the found account lookup OK variant. So this all looks right to me. It's not going to compile though because we haven't implemented all the conversion functions. But let's just look real quick and make sure that the errors we have are conversion errors. You can see that the first one is. The second one is not. I've gotten a type incorrect here. So I'm going to go figure out, okay. Again, I was pouring through this code for stuff that had to change, but I left this intact. This account lookup, okay. We're not doing an account lookup, we're doing a transfer lookup. Yeah, and it strikes me that like the stuff we're doing right now is all very boilerplate, right? Mechanical, just mechanical transformation. But we spent several weeks, building the infrastructure to be able to do this mechanically. And that's kind of a core tenet of good software development. Is you build up your tools to make your ongoing work kind of foolproof. And so the stuff we're doing today is boring, but it's only boring because we did the legwork to make it boring. Our goal is to kind of make our coding always boring, at least professionally. Maybe that's not what we want in spirit. Okay, so this, let's do a cargo check. And this type checks very suspiciously. That doesn't seem right. I'm gonna make sure how can this type check, y'all? Are all the conversions we need for this already implemented? Okay, that's probably what happened. Oh, that's nice. We're gonna be done with this. This was my whole goal for today, was to implement this method. But it seems like we're done. So what I'm thinking is happening here is that this submit transfer lookup, it needs to call these generic methods, and both of these generic methods depend on their type parameters having conversion implementations implemented. But we've already done one other lookup or a transfer related request before. We did the submit create transfer. So presumably when we did create transfer, we implemented all of the necessary conversions for submit transfer lookup. So this is probably done, and we can go write a little stub ad hoc test to see if it actually works. This is our main function, or our main method right here. So inside of the Tiger Beetle crate, this is all just one crate, a Rust Tiger Beetle crate, Tiger Beetle. We have both a library and a binary. This binary is just temporary. It's just for manual testing while we're developing stuff. Eventually we will create more intentional test suite for this, but right now we're just doing a bunch of ad hoc manual testing every time we develop something new. So here we have our old test accounts method that I've kept sitting around in case we need to go explore accounts again. And last time we started working on this test transfers method, You can see this is an asynchronous main function here. We're using Tokyo. It's just the basic boilerplate for setting up a main function using Tokyo, the Rust asynchronous runtime. And we're calling test transfers. And test transfers, again, this was just a copy of our up there test accounts method. And you can see we've commented out the code for doing the lookup. So let's uncomment the lookup code. And this transfer IDs, it looks probably right. And we have some transfer lookup, looks probably right. We're dropping this buffer just to verify that our lifetimes are working correctly. We want to make sure that this is a future. We call create a submit transfer lookup, and we get a future that we can wait on for the actual result. But I don't want this transfer lookup to hold on to this buffer right here. And so here we're creating the future. And then whatever data this submit transfer lookup method needs out of this buffer, it is making sure to take a copy of it and not hold on to this lifetime, because we want callers to be able to get rid of whatever buffers they're holding on to after they submit the request, or else they're going to have to do a lot of their own juggling of allocations when they submit many concurrent requests. So this drop here is just testing those lifetimes are defined correctly, that I can actually drop that buffer while I'm still waiting on the result. And here we wait on the result. I'm going to type check this again because I know it's not going to run. Well, we can go ahead and run it. You can see the server's not running. And over here, I think I already have, yeah, okay. I've already got a database that we've been working with. And this is the command to start the database. It's already got data in it. So when we submit the create transfer, it's going to fail because we've already created previously these two transfers. We can run this now. And, no panic. That's pretty much all we're looking for right now when we're doing these kind of manual smoke tests, is just no panic. In general, while we're developing Rust, we do a lot of type checking. Then we do a little smoke test to make sure it doesn't panic. And if it doesn't panic and it compiles, it's usually, more or less right. And so no panic here. Compiles, no panic. Great. You can see here's the result of the create transfer request. It says error exists because the database already contains that transfer. But here's the lookup. And this is one of the successful lookups. And you can see it's a transfer. So this all looks more or less correct. None of these numbers are very suspicious. This timestamp, again, I don't really know what it means or what it's used for, but all these numbers look right. So I'm going to, again, checkpoint what we've done, and we're going to move on to another request. So now we're going to be into a little bit of unknown territory. I'm going to step back for just a second and collect my thoughts, because I thought that would take, 2 hours to implement that method. But it took, let me check here. How long did it? It took 34 minutes. So with a lot of chit chat in between. So pretty good. We're doing good. Just checking out all my streaming stuff here. Okay, so now we're kind of into unknown territory, because thus far, I've really, in my mind, I've only held space for those 4 requests that we've already implemented: create accounts, lookup accounts, create transfers, lookup transfers. So those are the requests that I know anything about at all. And now it's time to go figure out what other requests there are. So let's probably go do some code diving into Tiger Beetle and see what else Tiger Beetle wants us to implement. This will at least be more interesting than doing another lookup. All right, I'm back to the code, remembering to switch scenes back to the code. And the state machine again. This is the, state machine. This is the Tiger Beetle source. This directory is a little bloated these days. I think we're going to start burying some of these support files elsewhere, but this state machine is like the core of Tiger Beetle. This defines pretty much all of the main types in Tiger Beetle. And it's, I'm not that familiar with it, but I know that every time we need to figure out what the data types are in Tiger Beetle, this is what I reference. And again, the operation is kind of the unit of a request. Like a request could contain multiple instances of a single operation type, but every time you send a request, you're sending an operation. Here is our operation. Where is operation defined? Is it in here? Oh, there it is. So here's the definition of operation. And so we have create accounts and create transfers, look up accounts, look up transfers. We've done that. So there's only 4 more. This pulse, I believe, is just reserved for internal communication between replicas. At least that's what I recall. I don't think I've seen it exposed in any client level APIs. But now we have to do get account transfers, get account balances, query accounts, and query transfers. And these sound very similar to the other 4 requests you've already implemented. There must be something different. Interesting. Look up accounts. Get account. Okay, get account. Okay, this is kind of like a relational query here. You're getting transfers for an account, and you're getting balances for an account. So that makes sense. This is just like a point lookup here, and this is some kind of relational lookup here. A range lookup, so a relational range lookup. And these are probably range queries as well, or maybe even more general purpose queries. But these are point queries, and these are going to be range queries. So that's going to be something new for us. We've only done a point query. In database terminology, a point query is when you're looking for exactly one thing. A range query is when you're looking for an unbounded or a number of things. Maybe not unbounded, but a number of things. So thus far, I don't actually know how the protocol level or the client level, how range queries are handled with Tiger Beetle. Probably there's some kind of cursor involved. So that's something we're going to have to learn here. So let's go figure out what this looks like from the data structures perspective. Actually, let's figure out, okay, we're going to look at a account filter and a query filter, kind of see which one of these looks easiest to start with, but they're both called filters, so I'm guessing all 4 of these are probably similar. But since this one is, well, let's look at the complexity of these filters and see which filter looks simplest. Where can we find these? I'm going to search for, my fingers are not working correctly right now. Filter, Tiger Beetle. Okay, so before I was saying like the state machine defines the core data type, but that's not quite true. It more defines the state machine for Tiger Beetle, like the relationships between the data types. The data types are actually in this TB namespace, which is tigerbeetle.zig. So Tiger Beetle is actually kind of structured as a generic database construction toolkit. Right now, it is a financial database, but it should be possible to say like, here's my data model, here's my state machine, mash them together, and I get a Tiger Beetle. And so this is the Tiger Beetle state machine. Tigerbeetle.zig is the Tiger Beetle model. And throw all this other code around those 2 things, and you have a database. And it should be possible to define other versions of the model in the state machine and create more databases. Yet to be proven. So let's look up our account filter. So here's the account filter. And actually, let's put side by side the account filter and the query filter. Query. Already, this is intimidating. A lot to look at here, a lot to think about. Okay, these are very similar. Very similar. Yeah, this is really just looking at, these are fields. Probably these are fields of the account. This is fields of query filter. Interesting. Query filter is not specific to a data type. Account filter is specific to accounts, but query is more generic. At least the name is more generic, just a query. Look at account filter on the right here. You can see you can filter by an ID. And remember the requests here are like query. I'm going to change my left-hand window over to the state machine again. Get account transfers. So this account filter, we would be using it to look up all the transfers for an account or something like that. So this would probably be the account we're looking up, and these would be user data on the transfers. So this user data is, for any purpose of the bank or client of Tiger Beetle. So if they had like, a meaning for user data 32, and I want to give a practical example, but I don't know banking really. But if they wanted to say like, this is for like a checking account or something, they could put it into user data and they could do a filter query for all of the checking accounts or something like that. I hope that is not terribly butchered. Yeah, I don't know banking very much. Okay, so these actually look pretty similar. So we're just going to start from the top and do the get account transfers. The complexity looks about the same for all 4 of these. So we're going to do get account transfers and just go down the list. And to do that, I think I'm just going to go start stubbing out that method and get the type checking going. And then we'll figure out all the types to plug in. And this, it seems easy right now, but we'll see. There's going to be a lot more to define here than the last request. It still seems relatively easy. And I'm not going to crib off of one of the transfer or account lookups because these types here are not very revealing and they don't require redefining a Rust type. These are just intrinsic primitive types, not intrinsic types. U128 is a Rust primitive. So instead of cribbing off that, I'm going to crib off of create account. This is a good one to crib off of because again, these generic types are more interesting and more similar to the request we're about to implement. So first thing I'm going to do is just stub out the method signature again. And back to our state machine. Oops, I lost my place here. Event type and result type. These are the 2 things I'm referencing a lot. And so there's a get account transfers. So we're going to say submit get account transfers. And this is going to be some kind of input type, an account filter. And then the output type is going to be a transfer. So we've already got that transfer defined. That's helpful. So we're only really looking at redefining account filter and anything associated with account filter. And this really might be pretty simple, again, to get this all working. It might be straightforward because we don't care about any of the semantics of what these fields mean. We're just kind of passing them through from the caller to the client library. Let's go ahead and type check. Account filter doesn't exist because I haven't defined it yet. So let's find our structs. And we have account transfer. And I'm going to make these in order of declared in tigerbeetle.zig. Okay, one thing that bothers me about Zig is that, well, like many languages, the type definitions and their method and code are kind of all interspersed in Zig. So in Rust, I can be like, here's my data. Here's all my data. Don't even think about what these data can do. Just have the whole data mapped out here. But over on the Zig side, like there's a lot of code here. I'm seeing data and code and data and code. Makes it a little hard to figure out where my stuff is. Okay, here's account. So here's the account type. So right now I'm just making sure that my declaration order of these redefined core data types are in the same order as the Tiger Beetle declarations, just for consistency and future maintenance. So when other people come along and see this code, they get a sense of familiarity. Like they know Tiger Beetle, then the Rust bindings will look familiar to them. Just always thinking about like how maintainers are going to see the code in the future. Here's our account transfer, and then create account stuff, create transfer result. So they have account transfer, then they have the results here. I don't actually like the way this is ordered. Maybe it makes sense. I've kind of ordered it a different way. I've said, here's the data types used by the database, and then here's like result types used by the protocol. I think I'm going to put my definition up here, actually. So in my mind, this stuff up here, accounts and transfer and the new account filter we're about to make are kind of like core data structures, and then these down here are just related to the network protocol. But then that's not really true because the filter is just related to queries. It's not really a data structure that is persisted to the database in any way. So I'm kind of flip-flopping here about exactly how I want to organize this code. Transfer lookup OK. I'm going to read their code a little bit more. Query filter, account filter, query filter, account filter. Okay. Okay, I'm going to keep their order approximately, and I'm going to say I'm going to copy all of these derives, keep my derives consistent. I'm just doing debug copy clone. And then down here at the bottom, in roughly the same order they're doing it, I'm going to say pub struct account filter. And then I'm not going to use these definitions because these are the Zig definitions, and there are several layers of abstraction removed from the C bindings. So I'm going to go to the Rust generated bindings and search for TB account filter T. Now this is the same structure, and it should be literally the same structure, even binary compatible. But the types are named in a way that is more appropriate for Rust. So I'm going to say, I'm just going to copy these fields, and then I'm going to rename the types in a way that makes sense for Rust. And the major thing I have to do here is I have to make, well, I'll do it this order. Remove these pub. Nope, these actually all want to be pub. These fields want to be pub because it's just going to be a plain old data type. The user is going to construct this, struct them themselves. And this data type is actually U128, which is the same data type, but we're not using this C definition. It's just a type alias for U128. This reserved here, I'm going to leave it, but I'm going to put a to-do. Because in the Rust API, we are not concerned about binary compatibility. We're concerned about type level compatibility. A big part of the Tiger Beetle data definitions are concerned with binary compatibility. So the Tiger Beetle is a very flat abstraction. So the account filter that is used by the database is the account filter that is used by the networking protocol. And so binary compatibility, the binary layout of those types is of huge concern to Tiger Beetle's design. But at the REST API, I don't think we want to be presenting that. That's not very rusty way to think about APIs. Is like, I don't think we need to do that at the REST API level for reasons I can't quite explain at the moment. But I'm suspecting we're going to remove this reserved field at some point. So I'm putting a to-do there. And again, these timestamps, I don't know exactly how they're supposed to be represented in Rust yet, how the user needs to think about times in the Tiger Beetle protocol. But right now, they're just numbers. Same for flags. All needs to be revisited at some point to make sure the API is rusty. Anyway, that's our account filter. Let's type check that. And I made a mistake in stubbing out this method. This says returning a future, so it's got to be an async panic. All right, let's checkpoint our work and start filling this out. This is going to be so easy. This is going to be so easy. It's kind of rewarding. Like, we spent multiple streams just kind of building this infrastructure for ourselves. And at multiple times I was like, is this too much? Am I kind of like building a cathedral here? Like maybe I'm just kind of like scratching my own itch to design code, which often happens. It's like I just want to make the code more and more beautiful, right? I just want to sculpt code because that's what I enjoy the most is just building abstractions and moving code around and making the code prettier and prettier. And so multiple times in this project, I've been like, is I really going in the right direction here? But now that we're actually doing it, we're doing the thing that we were building toward, and everything seems to be very easy now. It feels rewarding. It feels very rewarding. All right, so this, again, this create packet is doing a conversion from the Rust input type to the C input type. And so there's obviously, we're gonna have to implement a from conversion for that thing. And the compiler will help us figure that out later. This operation, we'll probably need to go look that up. I don't know if I can just guess it. Here's their operations defined in the bindings. We're doing get account transfers. So there's a TB operation, get account transfers. And down here, same thing, just boilerplate. And here we have to think about the results again. So this is probably what's happening. If we think about our API here, go back to the state machine. The result type for getting account transfers is a transfer. So probably what's going to happen is, actually, let's back up a second here. So when we get the result from the server is going to give us a result. We're allowed to submit multiple events. So that means in this method, we can submit multiple queries, and each of those queries can return multiple results. Does that make sense? That does not seem right to me. So here we're saying get account transfer, a single get account transfers operation returns a get account transfer. But we know that the results, we can return, you can get a list of results from the server. And it doesn't really make sense to me that we could submit multiple account transfers at a time. I wonder if there's a special case here where the client library is going to tell us, no, for get account transfers, you can only submit one event at a time. Because we submit one event and then we get back, many potential answers for the query. But if we submit many events and then we get back many answers for each of those many events, that is hard to understand. We would also have to have like a field in the result that says this is the query ID. And I didn't see anything like that. I mean, there is nothing like that in the transfer. If the result is a transfer, then I'm guessing if we submit multiple events, we're going to see like a panic in the TB client library. We're going to have to test that hypothesis. And if it's the case here, let's go ahead and look at, think about the semantics. We're saying get account transfers. So we're saying give us some number of transfers for an account, and the result is an arbitrary number of transfers. Then I think the algorithm we've actually laid out here when collect results is wrong, because we don't actually need to do that kind of correlation of results to inputs for this case, because every single result is going to be a result for the one input event. So I'm thinking that this is just not even the right thing to write in this case. And what I want to do is just kind of get rid of this, panic here, or to do here, panic, get what we have to compile, and then I want to test this hypothesis about what happens if you submit multiple queries in the same request. Because I'm feeling something is wrong here again about my understanding with the Tiger Beetle world. So we got to kind of go test our assumptions. But first thing to do is let's get what we've written here compiling. Get what we've written here to compile. Yeah. Check. And all right, great. Exactly what we hoped. There's exactly one error about a missing from trait implementation. So we have to implement from account filter from Rust account filter from C account filter. And that's super easy to do. If we go over to our conversions module, I'm just going to go do some copy paste. I'm going to take one of these and move down to the bottom here and call this, wait a minute, I'm screwing up. That's not the one I want to copy. We're going from a Rust type, to a C type. So I want to take this implementation, which is most similar to what we need to re-implement, and again, just replace types. From transfer, I think that's, no, account filter. Here's our error message, from account filter. From account filter for TBC account filter type. Account filter, TB account filter type. And then here, this is filter type, and then all these fields are wrong. So again, we'll go to our Rust bindings and find that TB account filter type and copy all these fields. And now we're going to replace that pub, replace string pub with nothing. And then these field declarations are going to be initializers now. So we're going to say other.account ID. And this is, straightforward. But like I mentioned, right now the representation of all the fields is exactly the same between Rust and C, but eventually we might remove that. We might change the time representation. So this might not necessarily be so trivial. Might not always be so trivial. I'm making a lot of typos while I'm talking about other things. Just duplicating these fields. User data 64. User data 32, code, reserve, other.code, other.reserved, other.timestamp min, other.timestamp max, other.limit, other.flags. Now this should all type check again, and we'll check where we are. Now let's go back to this method and think about how to test that assumption about multiple input events. I kind of want to just print all the results here, the kind of the raw debug print of whatever's in this message. And let's just go look real quick at what that message is, because I don't remember. All right, it's this thing, and this isn't debuggable on its own, but it looks like it could be. So I'm going to say derive debug. And here I'm going to print line message and do a pretty print. This is the syntax for string formatting in Rust. Here we can do a capture of simple variables here with interpolation of simple variables. And then all of this is saying, here's some modifiers to how we want to print it. Question mark says we're going to do a debug print. And this says we're going to do a pretty debug print. So by default, for whatever reason, Rust pretty printing just splats everything onto one line. And this makes it actually readable. So almost always need to do that if you're printing structs. And now let's run this. Let's think real quick. We got to modify our test program to exercise this get account transfers. So let's go over to main. And we're going to make a new one here. We'll call this get test get account transfers. And just copy some of this code around. We'll copy the code from the get transfers. And probably this is sufficient. I'm going to call this test get account transfers. This is submit get account transfers. And this all looks okay, but these fields are all wrong. This is now a filter. And let's look for our definition of struct account filter. Copy these fields. Get rid of these pubs. And fill this in with something. Account ID 1, 0, 0. So I think what I'm doing is I'm saying, give me all of the transfers for account ID 1. And I'm guessing if we think about how you do a cursor or a paging or something like that, I don't see like a cursor ID here or anything related to pagings, but I do see min and max timestamps. And basically every datum that goes in the database is timestamped. And these timestamps, I still don't really know if they're logical or physical timestamps. I think they're physical, but I assume they have to be ordered in some way. Like you can't just commit. Actually, you probably can create historical transfers. That's probably something you can do, but I'm not entirely sure. Probably if you have to do paging, like you need to read more requests or more responses to a query than available in a single message, you're probably going to be managing these timestamps. So not relevant to us right now, but in the future, we might need to add some extra helpers for paging to our REST API. Like, not strictly necessary. Like clients could deal with the paging themselves, and the kinds of programmers doing this are going to be very capable of doing that. But it could be like a nice to have to be like, we're going to manage these timestamps to just page through queries for you. Anyway, that's just an assumption based on what I'm seeing here. Hey, chat, Albert RPM TV. We're doing some Rust programming. This is the Rust client library to the Tiger Beetle financial database. Good opportunity for me to step back and take a drink and recap what we're doing. So Tiger Beetle, it's a financial database written in Zig. Tiger Beetle is completely written in Zig, but I'm doing some Rust programming on stream. This project is to create a Rust client for Tiger Beetle. It is bindings to a Zig library called TB client. All of the Tiger Beetle clients are just bindings to the core Zig written client. That might change in the future, but right now we're, linking some like a Rust facade, a pretty Rust API to the already working and solid client implementation in Zig. So this is a project that's kind of an exercise in writing Rust APIs, binding to the FFI, things like that. Testing, there's going to have to be a lot of testing at some point. We're not doing any testing yet, but that's what we're doing over here. And right now what we're doing is testing our assumptions about how the get account transfers request works. Because it seems like it probably works a little bit differently than what we are used to. I also noticed that, so this account filter does have a code, but it does not have a ledger. So you're not required to look up transfers on a single ledger. You can look up transfers with multiple ledgers. And that also suggests to me that a single account can be used across multiple ledgers, which I might not have expected. I might have expected that ledgers were kind of a way to partition the entire database, but that doesn't seem to be the case. And again, I'm not super deeply knowledgeable about how Tiger Beetle works. I just kind of am learning as I go. But it's interesting how much you discover just by looking how the data is organized, right? I don't know much about this at all, but just based on the data I'm seeing, I have a lot of assumptions about how this is going to work. All right, we're just implementing this query here. I'll only think real quick about what I've written and make sure this makes sense. So what I think I'm saying here is give me all of the transfers for account ID 1. Oh, yeah, I was just blindly typing stuff here and this doesn't make sense. Reserved, we can get a default implementation of bytes here. Timestamp min interesting. Presumably I have to give something reasonable here, though maybe it'll accept a sentinel value of 0 to be like the full range. But for now, I'm going to say whatever this was, this is a U64 max. This is the full range of timestamps. This limit is 0. Limit probably means, give me only so many results at a time. Flags is hopefully 0. And let's run that. Not working. So there's an error inside of our library. Let's see what line we're on. 184. Oh, this has to return something, and it's not returning anything right now, so it's just going to panic. And okay, the library looks like it compiled, but now the main function is not compiling. Oh, there's no default implementation for this. That is gnarly. Okay, so the reserved field here is a 58 element byte array. And in Rust, so far, there aren't predefined definitions for certain traits for an infinite number of array sizes. You can see this is probably exactly 24 or 25 definitions. So this particularly large array doesn't have an implementation of default. That is annoying. It's a limitation of the Rust type system that is partially resolved. Eventually you'll be able to do this, but right now you can't. U64 max. Why is this? Oh, this max is for comparison. I'm going to fix the easy errors here first, and then we'll figure out how to create that big array. This U64 max is going to be max value. And then down here, this has to return something. All right, now we just got this big thing here. One thing we could do is just remove this reserved field. And probably that's the thing to do, because this reserved field is not going to survive its way to the final API. I'm wondering if we should do that now. We're still going to eventually have to figure out how to create 58 bytes. So getting rid of this reserved field is not going to solve our problem of understanding how to create 58 zeros. I think, let's just think real quickly how to do this. How do we create an array? Almost every function that we would use to create this 58 element array would be a generic function that is not defined all the way up to 58 elements. You could do something like create an iterator and then collect that iterator into the array, but that collection method is not going to end up, there's going to be some traits that are not defined for a 58 element array. So not loving that right now. I'll just type out the thing that I would naturally be inclined to do. I'll say iter repeat 0.collect, and that will just infer that I need to create a container of zeros for however big the container is. I could probably say even maybe take 58, though that shouldn't really be necessary. But anyway, there's no way this is going to work. But I just want to see what the compiler says, like which thing here doesn't exist to make this work. Collecting into a vec integer, an array of, oh, wow. Wow. So this is a common enough problem that there's good error messages for it. That's pretty awesome. That is pretty awesome. So I don't know if these error messages originate from the compiler or from the standard library. Oftentimes the standard library is able to specialize compiler error messages in fancy ways that user code can't. But it's saying that I can't build this array. I could collect it into a vec, but that's still not going to help me get where I need to be, which is an array. With the result type, yeah. This is just saying, yeah, can't do it. I don't have the stuff. From iterator is not implemented. Yeah. So basically, somebody would have to define from iterator exactly for that, which in the standard library is going to probably be done with a macro. And eventually we'll be done with generic type level numerics, generic numbers, something like that. I'm really hating this right now. Anyway, users can't possibly be expected to do this. I'm going to remove this from the account filter type. Account filter. And if anybody in chat is a Rust expert and knows how to do this conversion without open coding a 58 element array, I'd be happy to hear it. But anyway, what I'm going to have to do, we can compile this, but this is not going to compile because our conversion that we've already implemented is expecting that reserved field to exist. So we still have to solve the problem. But here we can say like, I'm going to call it 58 zeros. And this is going to be, you're going to love this. You're going to love this. It's going to be so cool. Very elegant. This is going to be some elegant Rust coding here from our Rust expert. I'm going to create a static, now a constant, called 58 zeros. And this is going to be a type of U858. Also, there's another called zero or zeroed that sometimes can be used to initialize containers. Is there? Anyway, if there is, it won't work here. And this is equal to something. And I think I'm going to put a to-do here, just see if this to-do works in a const context. I don't know if it does or not. I'm going to type check this. And it doesn't like this because the array I've written here is not 58 elements. But I'm going to say, I'm going to make 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then copy that 6 times. 2, 3, 4, 5, 6. And then take away 2 of them. There we go. There we go. So now we're constructing that reserved hole in the struct. And now we can try to run our program. And let's look at what it did. It ran and it gave us something. So we got all the way to the completion method, so we didn't fail. And context, completion, context is something that we've defined. This completion message is something we've defined in our code in order to communicate between threads. It's not related to the protocol. I don't remember what context is, though. I'm going to open up that code on the pane here. Where's our completion message? Oh, context is, this is part of the underlying protocol that we're not using. I remember what this is. So the client library allows you to define a context. And this context is almost certainly for like correlating your requests with some kind of custom user data in your own client. But I have found that we have not needed to use it ourselves yet, probably because we're just capturing any kind of context we might need in our own Rust closures or something like that. With this context, we are setting it to something right here. Nope, right here. Nope, right, nope. Context. I'm going to find this. I'm going to find where we're setting this. Ah, here, it's in the client. So when you create the client, this magic number right here is the context. And I'm glad I made this a magic number. So I set this to be some recognizable value so that when I saw it, I'd be like, huh, that looks familiar or suspicious or something, right? It'd flick a curiosity in my brain. And now we're seeing that pay off right here because context is a strange number. And that reminded me, like, oh, I did that. So I know what that context is. And let's keep going and looking through what this output looks like. So we got our packet back. This is the thing we submitted, so it shouldn't be all that interesting. This is our timestamp. The result is empty. Now that's interesting. So we submitted a query. We were looking for all, the result is empty. So we were looking for a query. Let's see what query we were looking for. All of the transfers for this account ID, and we got no results. And that's suspicious. Like maybe it's true that there aren't any transfers for that account ID, but it feels incorrect. Though it could also be because we haven't, no, this should, I think this is a byte array. This hasn't been interpreted yet into Rust types, but I think this is just the raw bytes of the message result. And it's empty. Okay. Not yet implemented. That was something we intentionally did. So let's, again, keep probing our assumptions here and make sure that we do have transfers for this account ID. And I think I can just go to the REPL and do this. Cargo, not cargo, I'm doing Zig. Build run REPL, addresses 127.0.0.1. Oh, I'm in the wrong directory. Let's create another tmux workspace for this one. And Zig build run REPL addresses. And we're looking for account ID 21. So let's say, just do the same query in the REPL here and see what it says. I need to pass the cluster argument. And we're going to say get account transfers account ID equals 21. Okay, there's a transfer. So I said get account transfers, and there's a transfer. That is data. That's what I expected. But when we ran it, we did not get that data. I wonder if we saw an error. Maybe our request was not well formed. I'm going to look at our get account, submit get account transfers, and we did an await. And inside of our packet, there's like a flag for status. Completion message, packet status 0. That looks okay. So the server was happy with our request. And again, we submitted a filter for account ID 21. Code 6. I didn't put the code. That might be a difference here. So when I did the REPL, I didn't put code equals 6 here. Maybe that code, no, it seems okay still. But we could also not use this code at all. That seems more foolproof. Still no results here. Batch tail. Okay, so it did something here. These are internal fields that are used by the client and not relevant to what we're doing. Operation 133. I'm wondering if maybe I got the operation wrong. Get account transfers. Here's our packet. Just looking at our packet. Data size is 128, which is probably the size of account filter T. Seems right. It's not 0 at least, so we're telling the client we are passing it something. Data is 0. User data is 0. Data is 0? That seems wrong. Oh, okay. Well, this is 0 because we've already pulled the data out into an owned type. So this, when we submitted this, this was not 0, but now it is 0 because the data is this events array. This is now a owned Rust array. So when we created this owned Rust array and took ownership back from the client library, we set this pointer to 0. account ID 21, ID. This ID, what is this ID? Transfer 1, the first transfer. I'm going to look up a transfer 1 too, to see what that is. I'm going to say help, look up transfers, ID equals 1. Oh, this is the transfer. Yeah, so it seems correct. Code equals 6, code equals nothing. Just wondering if there's anything else we put in this filter that might have affected things. Maybe this timestamp, but maybe we have done this incorrectly. I wonder if it were somehow, this doesn't seem possible that we've done this incorrectly, where min and max are pretty straightforward. Maybe the conversion function I have screwed up. Min, max, min, max. Let's make sure we haven't, a lot of these are the same numeric types. Make sure we haven't done this conversion incorrectly. Timestamp min, timestamp max, limit, flags. All that looks correct. We're kind of at the point where I'm going to have to throw some logging into the Zig code in order to understand what's going on here. I'm kind of in panic mode now because, like, normally it's like I know what I'm going to do next, but now we have a serious problem to debug because I don't understand what I'm seeing here. So we're testing. We've submitted a query. And we're expecting some kind of results back, but we got no results back. And I kind of want to see like how the REPL deals with this. One thing I'm wondering again is whether timestamp min 0 is a valid timestamp or not. Sometimes zeros are sentinel values in Tiger Beetle. That might mean like something special. But I don't really suspect that. I would love for the REPL to just dump out what this filter looks like when it constructs it. And I might go ahead and do that. So I know a little bit about working with the Tiger Beetle REPL. Yeah, let's go ahead. Let's go ahead and yak shave for a while. Let's see, am I committed everything here? Not everything. Let's commit this, git push person. And let's go mess with the Tiger Beetle REPL. Tiger Beetle source REPL. Oh, there's a REPL. I have some outstanding PRs to restructure the REPL. I was just kind of wondering real quick whether the those PRs are in now, but it doesn't look like it. So here's the REPL, and if we look for, I'm just going to scroll down. It's not very big. Let's find do statement, operation REPL send. So right here, these statements are these operations. Parser statement contains an operation. Like this is the exact same data structure we're working at with our code. This is like a nice aspect of the Tiger Beetle flat abstraction design, that these data types are the same. So we should be able to just go print here, and then we can see how the REPL is constructing this filter. So here's a query get account transfers. And we can, now I have to remember, it's been a while since I've done Zig now. So I have to std debug.info. I don't feel like this is what I want to type. Let's see how other people in the REPL are printing stuff. Oh, the REPL uses special terminal stuff for printing. I'm going to say debug info, and then I'm going to be wrong. And I'm going to put some kind of marker here so I can see it in the output. And then I need to create a little anonymous struct to hold our interpolated string parameters. And this info is wrong. That was log info would work, but what I'm thinking of is debug.print, and there's no print line, but debug.print is what I'm thinking, I believe. I'm not a Zig expert. I'm learning Zig. And let's just print this operation and see if that builds. And we can kill our REPL over here. And this is going to be Zig build, and say Zig build check. This build check is a special Tiger Beetle build command that does a type check. The Zig compiler doesn't directly support doing a pure type check the way Rust does. But if you're clever enough and know enough about how the compiler works, you can implement something like cargo check in your Zig build script. So it seems to build the way I wrote it there, but let's see. I'm going to run the REPL, and again, we need to pass the server address to the REPL and cluster. And let's see if this prints the thing we want it to print when we submit an operation. Ooh, interesting. The REPL also has this kind of debug print method on it that I didn't know about, but that is presumably very similar to this. So let's say get account transfers 21 is what we're looking for. Hey, thank you, Barsguard. Nope, I wasn't sharing my screen. Thank you for telling me. This is a common mistake I am making lately. Gosh, how many minutes did I go there without sharing my screen? That's going to be really embarrassing for future viewers on YouTube when we put this up there. How many cumulative minutes have I recorded on this stream of not actually showing what I'm talking about? So probably it's appropriate for me to, I'm going to step back and recap everything I just did, because that was many minutes of doing stuff without showing you what I was doing. And now I'm back in my non-code scene again. So where are we here? Oh man, there's so much stuff you didn't see, Chad. I'm so sorry. So what we've been doing is we've been implementing Git account transfers. I'll go back over to the code. I'm on the code now. Don't forget, we're on the code. We're looking at the code. Thanks, Sparsguard. We've been implementing this Git account transfers method, and I'll unpop the stack here away. Git account transfers. This method for Git account transfers is a new request to Tiger Beetle. And we've already kind of implemented 4 requests, and we've established a pattern for implementing requests that should work, be repeatable across requests. But Git account transfers has, slightly different, seems to be a slightly different type of request, in that the requests you've already implemented, like on the right-hand side, submit transfer lookup. For every lookup, this is a point lookup. So for every request, you get a single response. And in here, we have multiple events or requests give you back multiple responses, but it's still one-to-one. For every input event, you get one output response. But this Git account transfers is a range query. And so that model that we've established here, you submit an array of events and you get an array or a vector of one-to-one results for those events, doesn't seem to work for a range query. So in my mind, it's probably like, range queries don't support multiple events at a time. You submit one query, get many results, but I don't know that. So we're kind of just testing what our assumptions about how Tiger Beetle works. And we've created a little test program to submit an account transfer. And it turned out that the account transfer didn't give us any actual results. So if I do my back scroll here, this is our test program. We submitted a Git account transfers query, and this is just the raw results. This is just a byte array, and it's empty. And that doesn't make any sense, because the query we submitted, which is right below it here, seems to be correct. and we tested this query in the REPL, it seems to be correct. When we ask for account transfers for 21, for account 21, we do get a transfer back, but in our code, we got no transfers back. So we're doing something wrong here. And this is kind of like a real bug we got to figure out, a real unknown here. We don't understand what we're doing wrong. So I'm modifying the Zig REPL, the Tiger Beetle REPL in Zig. And I'll show you, get back to where I was here. In the REPL, again, my code is now on screen. This do statement is what actually submits a statement to the server. The parser statement directly contains an operation. Operation and event are almost interchangeable in the Tiger Beetle lingo. So if we have a get account transfer operation, this is submitting it. And this data structure in Zig is the exact same as the Rust data structure that we're dealing with. And so I'm trying to just print whatever the REPL is submitting to the server to make sure that make sure the REPL isn't doing anything with this query that we're not doing. And so here I ran the REPL. This is the REPL, my modified REPL. And you can see this when I printed it, it's printing nothing interesting. Probably because this operation is not the thing I need to print. So I'm printing the operation. Operation is just printing this right here. It's not, this is being printed by the REPL itself. And in fact, to make sure that's true, I'm going to say a few more new lines there. I'm going to run this REPL again and just try one more time. Ooh, this takes a while to build. Get account transfers, account ID equals 1. And I wanted to do 21. Okay, there we go. So this is what we're printing, and this is the response. And this is the response we expect to get, but we're not getting in the REPL, or in the client, the Rust client. So the thing we printed here is not the thing we need to print. The state machine operation, this is probably what we want to print. So here we're saying string to enum. Nope, statement arguments is probably what we want to print. This is probably just a byte that says this is the kind of operation we're sending. Let's see what's in the statement arguments, but I'm suspecting statement arguments here is going to be just a byte array, so this is probably not going to be helpful. We might need to go do this printing elsewhere. But let's just see what's in statements.argument, statement.arguments, and see if that'll build. This might need us to, needs a specifier here because it's just a byte array. And in Zig, byte array could be a string or it could be something else. I actually don't know what this any specifier does. I'm not that familiar with Zig, but I'm going to put any there because I know this isn't a string. I'm going to see what it prints if I put any there. And it's probably going to be too hard to understand on its own. Although the structure we're printing, the account filter, is a pretty simple struct, so we might be able to like pick out the bytes and figure out what the fields are. 21. Okay, so yep, there's our bytes. And you can see we got 21. That's the thing we're looking for. And this is, again, these IDs are U128, so the field is like that. And then there's some stuff down here. And this is, again, this is the query filter. So this might be related to the timestamp. So just real quick, let's go look at our code again and see what we put in there. So we did put in some kind of timestamp. But interestingly here, when we submitted our query, we only specified account ID, which is this. And somehow some other values ended up in the query. So we didn't specify the timeout. We didn't specify the code or the flags, but there's some other data here. I'm guessing some of this is related to the timeout. Some of it might be something else. So there might be stuff here that we're not doing. And if we think about how the REPL constructs these inputs, the REPL parser is very simple. It's kind of doing a lot of meta programming to say, like, if you give me a string with a field name that corresponds to the Tiger Beetle operation field name, then I'm going to just parse it into that type and construct the Tiger Beetle operation struct from the name of the field that you gave me. So if we look at the REPL documentation here, the way the REPL is constructed is so simple. All of these values here to create accounts are literally just field names of the type that is passed to create accounts. So this is all meta programmed here. There's no open coding in the REPL to say what is an ID or what is a code. It's just looking at the structs involved in looping over their fields, which makes it easy to write the REPL, harder to read the REPL though. So there's kind of nothing for us to look at to figure out what is it doing in the case of get account transfers. But I might surmise that the way it is constructing these structs is to initialize the structs with a default value, and then as it's iterating over those fields in the parser, it's overriding the default fields with whatever the user specified. So I want to go look at the definition of query, whatever this thing is, query filter, account filter, and then just see if it has default fields that make sense for us. Because if it has default fields, then we're going to also need to kind of replicate those default fields in the default constructor in Rust as well, which is something to be aware of and know. Because the user can't be expected to figure out that there should be a 3 at this particular field, probably. Anyway, the account filter is specified in tigerbeetle.zig, and here's account filter. And there's nothing default specified right here. Oh, right here. Chat, check this out. There's some documentation here. This is great. So, right here, you must have some kind of limit. And this makes so much sense if we think about what this field actually means. You know, when I was writing this test, I was like, yeah, 0, 0, 0, 0. But one of the fields here is a limit. And that's definitely like a limit to the number of responses to return. And I said just limit 0. I blindly said limit 0. And almost certainly that limit is this 3. So somewhere in the REPL, we're saying, yeah, give us at least 3 of these things. Interesting though, because I don't know where that code lives in the REPL. I don't know where that code might live in the REPL, and I'm kind of curious where that 3 came from. And almost certainly this is related to timestamps, and I'm very curious where those timestamps came from. So I really still want to do a little digging and understanding what this is here. But almost certainly our bug is that I didn't tell it to return any results. I said, give us exactly 0 results, and it gave us 0 results. So let's go confirm let's go confirm that, and then we'll do a little digging and figure out what those other numbers are. Because there's some stuff to think about here about default struct initialization. So our code is back in main.rs, and I'm going to move back to our source Rust, source cd source clients Rust. Make sure I'm still showing you the code. And in our main function, let's put a limit of 3 there. And these timestamps, we now know from reading the docs. This is interesting because a lot of the Tiger Beetle code is not particularly well commented, but this is exactly correctly commented. These are core data types. So even like Tiger Beetle internals developers see this, but also this stuff is very relevant to users of Tiger Beetle. And this is well developed or well commented. So timestamps, you can put a 0 here. And like we were speculating like a half hour ago, Tiger Beetle does realize zeros as special sentinel values and gives them special meaning in a lot of cases. And in here, timestamp of 0 has a special meaning. It means ignore the timestamp. So this limit, we have to put something there. It's interesting, it says the limit must be greater than 0, but that doesn't seem to have been true because the server was happy to return us 0 results successfully. But if the limit must be greater than 0, then you would expect the server to return us 0 results with an error. So interesting. So we've changed our limit to 3, which is what we think the REPL used. And now we can just cargo run this. Cross our fingers. Oh, we already ran. Sorry, I wasn't looking at my screen. I'm just sitting there with my fingers crossed. Completion message. Still no results there. So we did pass at a 0, a 3 limit, right? Oh, that's our reserved 58 bytes. Limit 3. Still no results, though. So we still haven't figured out the problem here. We're searching for account ID 21. Still no results. Okay. We got to keep digging. I'm going to run that REPL again and just reconfirm that account ID 21, account transfers, account ID equals 21. There we are again. These numbers look the same still. So there's still, this is probably the limit, and there's probably something else that has some kind of constant value. Interesting. I still want to dig into the REPL and figure out what these numbers are and where they came from. So I think what I'm going to do is dig through the parser, and I'm really in uncharted territory. I don't know what I'm doing here. I mean, I kind of know the REPL, and I kind of have some idea of the parser, but definitely flailing here. So somewhere in the parser, we're going to parse statements. And I'm hoping that somewhere in the parser, we're going to have a concrete operation type that we can debug print, because all we've found so far is the final byte buffer that represents that operation. All right, here's parse arguments. Here's an operation. So here's we're parsing the fields of the operation. And I'm wondering if at the end of this function, we can see the final constructed object somewhere down here. If object has fields, we're doing something. We're doing some kind of iteration over the fields of the type that we're interested in. But we're still just looking at the fields here. We're not looking at the actual constructed type. And there might not be anywhere in the parser we do. It might only deal with fields. But I also, so one thing we do is we debug print all the fields here, because we do kind of like dynamically construct the correct types for individual fields here. I assume. No, we might just look at the bytes of the fields. So again, we might not be looking at the actual typed values of the fields, just the bytes. But we do see the names of the fields here and the bytes of the field. So we could debug print the name of the field and the bytes in the fields. And that would at least narrow down our search to knowing what fields the REPL is setting. But before I do that, I kind of want to look at who is calling parse arguments and see if they ever look concretely at what this value is, this struct. Though I kind of think they don't. So on the right-hand pane here, I'm going to search for parse arguments. Here we're again switching over the operation. Oh, let's switch windows here. Swap. Window swap. Parse arguments is what I'm looking at. So when we parse arguments, looks at the type of operation and then switches on the type operation, and then look right here. Here's where it creates the initial request the event to fill in with fields. And this one right here is a complicated case for the thing we're working on, account filters. So for both get account transfers and get account balances, we're constructing an account filter. And these are all zeros, which makes sense for us. Limit, interesting. So they, in the Zig side, they statically know the correct limit for get account transfers and get account balances. And interesting, we're searching for get account transfers, and we were assuming, I was assuming that this 3 was the limit, but if we're putting in like a constant limit, 3 is definitely not the limit, right? You can certainly return more than 3 transfers at once, so that can't be correct. So that also tells me that in Rust, we're going to need to provide some kind of a convenience here, like give the you're gonna have to give the user access to these constants, or kind of like proper initializers that automatically set these constants on the account filter, because this is impossible for the user to just figure this out. So in my library, I'm going to make a note of this. Up at the top of the library, I'm going to put a little to-do. It says need to provide filter limits. Get account transfers. Let me see, what is this? Constants.batch max.get account transfers. Batch max.get account transfers, etc. So someday we need to consider this when we're in our design of the REST API, that the user is not going to be able to figure out what these two constants are. And I'm just making a note of that, but we can't tackle that right now. We are deep in the weeds here. Okay, so this limit has to be set correctly. And then credits. Oh, okay. So these flags look important, right? By default, it looks like we're searching for nothing. But we probably want to be able to say like, no, we're searching for credits, or we're searching for debits. And in the REPL, it explicitly says we're searching for credits or debits. So that means we've got to go deal with flags. And again, this is something the REPL is going to do this by default, because it's kind of like making a decision for you. But a programmatic Rust client is not going to just default to searching for all credits and all debits. They can figure out how to set these flags correctly. But these constants for the transfer limits, they definitely can't just know that number out of their head. But this tells us almost certainly this is the mistakes we've made here. So probably I'm going to go to main, and for this limit, I'm going to make a guess here, and I'm going to say 254 is the limit for transfers. I'm going to just hard code that in my test, 254. And then flags we have to set correctly. Now this, we could just copy this 31. That is almost certainly the correct value. I wonder where, before we do that, we might just, for the sake of testing, I might just put a 31 right there. But I'm still curious where this flags is defined. This bit field, flags is a bit field. And I'm guessing that, so Zig has like first class support for integers with arbitrary bit sizes, which is a pretty uncommon thing. But you can say like, I'm just kind of speculating how flags is defined. This might be like a 1-bit integer or something like that. But I want to go look at flags. I want to see what flags is in Zig, so I can kind of understand how to set credits and debits correctly in Rust. So this is account filter. It is in tigerbeetle.zig. Account filter flags is in account filter flags. So let's go search for account filter flags. And this is it. It's a packed struct in Zig. Okay, so this isn't, I have no idea whether Zig supports a notion of bit flags, but this is a packed struct. And so the bool is a 1-bit bool. And credits is a 1-bit bool. So Rust, I have no idea what Rust does with packed bools. I would guess that it does not promote them to bits, but I actually don't know. Packed structs in Rust are pretty exotic. They kind of exist, but they also have a history of like being impossible to use because of undefined behavior reasons. But anyway, this amounts to being a bit field. It's looks like 32 bits. And so here we could say like, we could define some flags. And I'm going to go ahead and do it just for the heck of it for my own future documentation so I remember what the definition of debits and credits are, and also just because I kind of think at this point in the stream, I kind of want like a fun computer science diversion, kind of remember how to use bit fields and bit math. So I'm going to say const credit, I'm going to call this, I bet this exists in the C bindings. Kind of no reason to redefine these. But let's go look at these C bindings and see if they've automatically generated this. This is a complicated data structure in Zig. I wonder how it translates to C. Let's go look at client.h. This is the C header for the TB client API. And I bet if we look up TB underscore account filter flags, we'll find something interesting. Yeah, so it's already been given to us, so we don't really need to do anything special here. So in the Rust library, I'm going to kind of re-export these and rename these for now, but eventually we'll need to kind of create a Rust-specific abstraction for these types of flags. But for now, I'm just going to say pub use TB client. And before we do this, I want to look at the Rust definition, because the Rust definition is, these are probably just going to be constants in Rust, and they're probably going to be named slightly different. So we're going to look for account filter flags in the Rust bindings, tbclient.rs, and search for account filter right here. You can see the bindgen, the Rust program for generating Rust definitions from a C header, has prefixed these flags with the name of the enum, because it didn't convert the C enum to a Rust enum, it just converted it to a bunch of constants. So this is TB account filter flags, TB account filter debits. And I'm going to re-export these, and again, this is just going to be temporary. I'm going to say TBC filter account filter flag debits equals TBC, that big mouthful. And then I'm going to say to do temporary. And this is going to be credits. And there's one more called reversed, which interesting to note. If you want a reverse paging in the query, you can get it in reverse. Reversed. Okay, and then in our test function, and this limit, I'm going to go ahead and define something for that as well. I kind of wonder whether the header exposes this number. That would make sense for the header to expose this number because it's just a weird number, right? I'm going to look at, real quickly, I'm just going to search through the header again, TB client, and look for, here's the filter code. I just want to see if there's anything related to limits in here. And if it doesn't seem like it. Those would be good constants for the header to expose. Anyway, it seems like the query limits are not exposed by the TB client header. All right, now in our main function, we at least get to experiment with doing a little bit of bit math with some XORs or something like that. If we think about how we turn on the credits and debit flag, these are going to be Debits flag is going to be a 1 in the least significant bit, and then the credits flag is in the second bit. And so we're probably going to be ANDing these together. Nope. If we have a 1 in one place and a 1 position, we're going to exclusive OR them together. So here's our debits. It's a 1 and a bunch of zeros. Here's our credits. It's a 1 and then a bunch of zeros around it. If we want both of them at the same time, we take that 1 over here and the 1 over here and say, splat these together. And if this one is a 1, we get a 1. If this one's a 1, we get a 1. And who cares if one of them happens to be a 0? So if either of these positions, these are positions in a byte. Position 0 is a bit 0, bit 1, and then more bits over there. If either our credits or debits bits are 1, then the result is 1. So we're going to XOR. And that's common bit math, but I always have to kind of rethink it from scratch every time I do it, because it's not like I'm doing bit math all the time. So here we're going to say TBC, and remember what we call these constants. Pub use TB. The syntax I wrote here, chat, is completely bogus. This is just all wrong. This is crazy. So I wrote this kind of like a type alias, and that's probably what I'm going to convert it to. What I wanted to say was pub use C definition type as Rust type. This says import this type and re-export it. Import this name and then re-export it as this name. But I wrote it more like a pub type C type equals Rust type equals C type. So these are kind of two almost equivalent ways to kind of take one name in Rust and repackage it as another name. And I just kind of like split the difference and wrote it completely wrong in either way. But I'm going to call this pub type. And these are not types, actually. These are values, so this is not actually going to work. The type alias does not work for this. So we're going to say, grab all this stuff and put it over here. Now that's how you write a re-export in Rust. And this TBC is not prefixed here. Oh man, I was just completely blanking on that. I'm sure it was because I was talking to chat. So it's, I shouldn't say this, but it's your fault, chat. Not my fault. Okay, reorder all this stuff. And that's nothing. All right, back to our code here. And actually I needed that because I forgot the names of those again. Account filter flag debits. So finally we can write that. And this is in the TB module. XOR credits. All right, now we can check this. So this has been quite an expedition to go figure out why this account transfers didn't work. And ultimately what we learned was the timestamps you can zero out and say just ignore the time range. And the flags, chat, that is wrong. That's the limit there. This is the flags. Thanks, S. Barsgaard. You and me figured that out at almost the exact same time. So our flags have to be turned on in some way to say what we're querying for. So before we were just saying flags was 0, assuming it was a valid query. But what we actually ended up telling the server was we're querying for no types of transfers. And what we actually have to do is say we're querying for this type of transfer or that type of transfer. So we're doing a query for both debits and credits. And this limit, we can't set it to 0 or else it's going to give us 0 results. This limit has to be something, and I think we said it was 254. But I just kind of erased it and rewrote it again. And this we have to come figure out how to provide that constant to users on our API eventually. So, and we learned all this from kind of running the REPL and debug printing the REPL, figure out how the REPL was making this query. Now, I believe this is going to work. I don't know if it's going to type check, but I believe it's going to work now. So let's go to the moment of truth, back to our Rust directory, source clients Rust, and let's see if that's not the right run. Cargo run, and something is wrong here. Looks pretty minor. Credits. I appreciate that you were paying attention, though, SparseGuard. That always makes me happy when somebody notices my errors before me. So we got our completion message, and now there's stuff in our results array. So that gigantic odyssey, before we were not getting any results, and now we're getting some results. We're not interpreting those results yet, but we are getting some results. So I'm going to, we modified the zig REPL. I'm going to undo that real quick. Git checkout source, no, git reset source REPL.zig. Git checkout. I always forget the differences between checkout and reset. There we go. No longer making changes to the REPL. And checkpoint our work here. And think about where we were. We've got to pop the stack a lot here because that was a big ol' yak shave to figure out what that bug was. But if we remember what we were doing so long ago, we are writing the get account transfers method, and we had a hypothesis that this does not actually support multiple events at once. So I kind of want to say, I want to call get account transfers with multiple events and see what happens. Like whether the client complains or the server complains or nothing complains. Because I just don't see how this can support multiple queries at the same time, given the protocol that we're seeing. And before I do that, though, I just kind of want to chill for a second. My fingers and my head have been going nonstop for 2 hours now. Pretty tiring. I'm really pretty happy with the soft lighting on my camera today. Oh, I'm just taking a breather. I'm just taking a breather for a second. What I want to do is have a wide studio camera over there so that when I'm just like pacing around this room, I can do a wide shot. All right, so I think what I'm going to do next is good idea. Let's just chat SparseGuard. Never used Rust. Oh, great. So SparseGuard is learning a little bit about the FFI here. It's interesting because you say you've never used Rust with C, but binding Rust to C is like kind of bread and butter stuff in my experience with Rust, at least in the kind of work that I've done with Rust. There's often a lot of adding Rust to other projects and things like that, or exposing some gigantic chunk of C, C++ code to Rust. So there's a lot of kind of FFI bridging in the Rust world. And Rust is pretty good at it, but not amazing at it. But it's like Rust is like good enough at talking to FFI that there's not a whole lot of emphasis to make it better. It's always kind of like talk in the Rust world. Like we got to be better at doing FFI and making it easier to interact with C++. But like for the kinds of like projects where you do need to interact with, a legacy C++ code base, the tools are good enough that your highly paid engineers can go spend the time to make it work. And so it doesn't really need a whole lot of, the experience, could be a lot better, but it's sufficient. So people love to talk about how great Zig's FFI is, mostly because it has Clang built in, and it's done some really amazing things with packaging and the cross-compilation toolchain, which Rust, I think at this point, could copy what Zig is doing and get better cross-compilation, and probably should. Like in the initial development of Rust, we got really far, and Rust cross compilation is like way better than C++. So it's like, hey, it's pretty good. It's a big improvement over the state of the art in cross compilation and systems languages. But then Zig is just kind of way better, just because they've done a little bit of extra grungy work to package up the right tools. Though I haven't used Zig's cross compilation in practice and don't really know how thorough it is and how good of an experience it is when you consider all the possible options that you might cross compile between. And I suspect there's rough edges there, especially when dealing with Windows stuff. Though I know they've done quite a lot. And it also helps that the LLVM toolchain has evolved a lot in the last 10 years, and that Microsoft has contributed to LLVM, and they have things like Clang variants for the MSVC compiler and stuff like that. Like maybe Clang can just speak correctly all the right ABIs now, and pretty awesome. Anyway, I'm just chilling, blabbing about FFI before I buckle down and get back to work here. I would like to finish this last request method before I sign off today, and it's been a bit of a yak shave today. Ooh. Sparsgard, how much, what do you do with Rust? What kind of stuff are you doing with Rust right now? I assume you know a fair bit about it since you're making helpful comments. All right, anyway, I'll pay attention, but I'm gonna get back and start making a little more progress. Okay, so again, I'm starting to, the wheels are starting to turn slower now. The wheels are really moving slow. I'm also, most of my coding is hobby projects. I find that I'm very excited about my hobby projects that mostly don't go anywhere. And so I spend a lot of time just piddling and messing with the type system and designing pretty code and then throwing it away. Like right now I have 2 hobby projects in Rust that I've been very excited about. Like I was up till 5 a.m. last night just hacking on stuff related to trying to learn Prolog, and so I'm trying to build a Prolog interpreter. But of course, every time I build a compiler, I'm just gonna keep chatting, I'm bored. Every time I build a compiler, I kind of get really deep into the parser, and I never get much further than the parser. I'm just like, I have so much analysis paralysis about like how should I structure my parser, and how should errors be handled in my parser and things like that. And should I use a parser generator or a parser combinator, or should I open code a recursive descent parser? And I'm hoping that this time I'm going to push past the parser and I'm actually going to start writing some Prolog logic. Yeah, so does that mean you're able to do some Rust at work, Sparsgard? That's very nice. I don't pay a lot of attention to the Rust subreddit, but I see a lot of people complaining that they can't find Rust jobs. So I'm going to keep going, and but yeah, like a lot of people write Rust not very low level. Like I also do a lot of like web servers in Rust, a lot of async web server stuff, and web services at least are great for Rust. Rust is great at writing web services, and that's not very low level. Okay, so I'm going to try to submit 2 account filters at once and see what the response is. So in our main function here, I did 1 account filter. And here I'm going to try to give it 2 account filters. And I'm thinking this is an error. But let's see. Okay, so something happened here. This doesn't look normal. Client session evicted, invalid request body. Okay, this is good stuff. So it looks like be aligned and non-null, not to exceed isize max. Oh, this is not entirely sure what this is actually. this looks like my error. So what I think happened here is that I sent an invalid request, and then the response to that invalid request was probably something that my unsafe code was not structured correctly to handle. Because in previous streams in this series, we've seen this particular error before, and this is a pretty heinous Rust error right here. So this is the standard library figuring out that we tried to construct a slice from a bogus pointer. So probably somewhere in my code that handles error response, I did not take into account what would happen if this pointer I'm looking at is null, or maybe not null, maybe some kind of sentinel value. So we're going to get a backtrace here and see what's going on here. But this is great because at least we were correct that for this particular request, it looks like probably we're not allowed to send multiple events at a time. So progress. What's going on in chat, Sparsgard? Rewriting your backend in Rust. Oh, last job. Sparsgard, thanks for telling me my screen was not shared. You are my buddy today. You're my buddy today. All right, Sparsgard, I appreciate that you did some Rust at your job. I'm going to go recap what I did here for the stream. So we're testing whether this works with 2 filters or not, so 2 queries at a time. So I updated my, gosh darn it, that's twice today. That's twice today, y'all. One time I did it 4 times, where I forgot to share my screen 4 times. So we updated our query here, get account transfers, with 2 queries, which the protocol allows. It allows you to pack multiple things into a single query, or pack multiple events into a single query. But for this particular type of event, does not seem to be allowed. And we got this big nasty error message here. One here is like a debug logging error from the client library that says, we were kicked out. Our client was kicked out of the session because of an invalid request body, which is good. That's what we were hoping for. And then we had this really gnarly error printed from the Rust standard library about using an unsafe pointer incorrectly, which is a very nice thing that the library is able to tell us. It didn't just infect us with undefined behavior. So we got to kind of do a backtrace here and figure out what this code was that handled this error incorrectly, but we're on the right track. And I can do this again with Rust backtrace equals 1 like it tells us. And here's a pretty nice backtrace. This is actually a strange backtrace because at the bottom of my stack, I'm seeing Zig call stacks. Oh, I got it. So this is not on the main Rust thread. We're running a Rust program right now that binds to Zig code. So I would expect the main thread to have the bottom of the stack and our top. Just the first call frames be Rust frames. But our first frames here are Zig frames, but that's because this is being done on some other thread. So this error is happening on the Zig event loop thread where we receive callbacks. And so here's the Zig event loop. And if we scroll up, here's where we actually panicked in the Rust code. And you can see there's probably some place here we can see right here, transferring from Zig code to Rust code. Here's our on completion. This is the callback. This is just a plain old Rust function. And I want to make sure this on completion, this has got to be a CABI function. Presumably it is. Just all of a sudden I have this panic feeling that, did I define that function to have the right ABI? Yeah, and it is. It's a C function. All right, so we're getting a completion. And then this is just all Rust closure glue. Here's our create packet. This is the generic function, and this is a closure within create packet. So this is one of our generic helper functions. This line 434 is where the error is. So we're doing something wrong here with the pointer that we're calling from raw parts from. So I want to go give that a look and do some debugging here. This is line 434. And on line 434, we're constructing a slice from raw parts from the result. Okay, this is great. This is very similar to another error that we ran into a few streams ago, but with a different slice. So what's going on here is that this result here, let me back up real quick. So we've seen this bug before, and this is a pretty nasty bug to run into with unsafe code. It's one of the hazards of writing Rust unsafe code. We are trying to construct a slice from an unsafe pointer, and then subsequently from that slice, we're trying to create a brand new vec. So in this piece of code, this is a callback. So this is when the Tiger Beetle client is done handling our request, it calls our code so we can do something with it. And this happens on a different thread from our Rust event loop. This happens on a Tiger Beetle event loop thread, basically. So we have two parallel event loops, and this code runs on some other thread that is Tiger Beetle's responsibility. And in our callback, all we're trying to do is reclaim Rust ownership of a whole bunch of pointers and then pass them back to the main Rust thread. And we want to do as little as possible right here before getting back to the other thread where we want to be doing our actual work. And the reason that the goal here is just to reclaim ownership of pointers is because we want, like, every moment that somebody is responsible for freeing this data if something goes wrong. If there's an error, all these heap allocations, somebody has to be freeing them. And so from the moment that we call submit request to the Tiger Beetle library, we are handing ownership of a bunch of Rust allocations to the Tiger Beetle library. And at that point, Tiger Beetle must, like the TB client's contract is that it must call this callback at some point so that we can take back ownership of those heap allocations and free them. And if Tiger Beetle doesn't call us back, then those heap allocations are lost. But also, what we're doing here is we're sending a message back to the main event. And we need to take ownership back of these allocations before sending them back to the main event, because this message may never be received. So there's no guarantee that the original calling code will ever look at this message. Like, what if the main thread panics? Then this message is just lost in transit. And so we need these heap allocations to be owned by this message. We can't wait to reclaim this ownership of these heap allocations for the other thread, because if this completion message disappears, then the completion message will free all these allocations. So that's the whole point of this callback, is freeing allocations. Or not freeing allocations, but reclaiming ownership of allocations. So here, this events is the input event vector. And this was originally allocated by Rust. And here we're saying, okay, we own it again as a vector. So when we called the client, we said, take this Rust vector and just turn it into an unsafe pointer with no owner, then pass it to TB client. And then here we say, take that unsafe pointer with no owner and turn it back into a Rust vector so it has an owner again. Same for packet. This is allocated by Rust, and here we're reclaiming ownership. Result is different, though. This result vector, or slice, or array, is allocated by the TB client library specifically for this callback. So what we're trying to do here is say, take this array that is not owned by Rust, it's owned by Zig in the TB client library, and look at it as a slice so we can deal with it in Rust terms, and then convert that slice to a vector. And at this point, this result here is owned by Rust. It's a heap allocation in Rust, and we can pass ownership of the slice right back to the TB client library. Because as soon as this callback stops executing, the TB client library is going to reuse or free this slice, this array, this allocation. We're not allowed to look at it anymore. So one of the things this callback does is just immediately copy that result to a new heap allocation for Rust to use. Because as soon as we send this message, we're exiting this callback, and TB client is off doing its own thing again, reusing that allocation. But as we've learned previously, if this pointer is a 0, we think, There's conditions around how the internal pointer for Rust slices are managed. And it seems like if this is a 0, we cannot create a slice from it, even if the length is 0. Like this has to be a pointer. And my speculation for why this has to be a valid, it doesn't have to be a valid pointer, but it can't be 0. So internally to Rust collection structures, they're fairly sophisticated in how they handle their layout. And most Rust collections reserve the 0 pointer for a specific purpose. Rust will like pack structs tightly if it can and realize that like the 0 representation of a pointer is not valid. And so that I'm going to reuse the 0 representation of a pointer for other purposes. And that happens a lot with like enum variants or enums containing enums. Oftentimes they'll reuse pointers, 0 values for other purposes. And so it's not really valid to create a Rust slice with a 0 pointer. And so far we haven't hit that in this case, but we did run into that in another case where we saw a 0 pointer. And I'm still a little unclear about the rules here. But what we found out that we had to do was we had to account for like, if this result pointer is null, do one thing. If it's not, do another thing. And I want to go look at real quick the other place where we had to do this. And that's it right here. And I'm kind of confused right now because we're looking at a result here and we're looking at a result here, but are these not the same results? This is a byte of results. This is a result. This is a result. These seem like the same results to me. Slice from row parts. Oh, I see. I see what's going on here. So these are both the same array, and we're doing an unsafe conversion to a slice in both cases, but we're doing slices of 2 different types. So here in the callback that we receive from Tiger Beetle, this is just a byte slice. But our requests are typed, and the results for each request are typed. So here we're creating a slice of bytes from the result. And then over here, we're doing another unsafe slice in order to convert that slice of bytes to a slice of some type. Here it's a generic type parameter called cResult. So we're doing this exact same pattern unsafely, constructing an unsafe slice in 2 different places. And it's interesting because I kind of would have expected this failing slice to have failed previously in the same cases that this slice failed. So I'm a little confused about why this has not failed until now. And what I think I'm going to do is do a print line and print what this pointer is, and then maybe print what this pointer is. It's also kind of not worth really digging into. Like, we kind of know what the bug is, and we can fix the bug. We just got to account for this null result pointer. But I feel like I'm confused, chat, because other requests we have made have resulted in no results. And I'm curious whether TB client was sending us 0 pointers here then and not now, and like what makes this request different from previous requests. So the obvious difference is that this request is an error request. So we gotta, the obvious difference is previous requests were successful. This request was not successful. This request was disastrous. Our client got evicted. So there must be some difference in like what this pointer looks like in the case where there was a complete failure to send the request or to receive results. So I'm going to do a print line here and just say result pointer is result pointer. I want to look at what this pointer looks like. And then I'm going to construct a test case that prints this pointer for the succeeding empty result cases and this failing empty result case. So go back to our main function. I hope you could follow all that, because I'm a little confused myself, and just trying to explain what I'm confused by is stumping me a little. But I want to go create a test case. We'll just reuse test get account transfers, or maybe we can use test accounts. So what we want to do is we want to submit a request that receives no results but successfully. And to do that, we can probably do test account lookup. I think we have something called test transfers. Test transfers should work. Sparsgard, thanks for the rubber duck. I appreciate that. Honestly, that is one of the, I've only started streaming recently, but one of the nicer things about having, people in chat, challenging you sometimes is just the rubber duck aspect, and talking through every single thing on stream. It is rubber duck debugging totally. And it, for as slow as streaming coding is, there are some unique insights you get just from saying every single thing out loud. So we're going to run test transfers. And then we're going to make sure this test transfers function does something. I'm going to create a transfer, and then we're going to, I'm going to have to add some more print lines here. Print line. Am I doing ePrint line or print line? Print line. Transfers in here. Get account transfers. Just making some visual dividers between all this gibberish we're about to print. Sparsgard, you you deal with what do you call students that work for you? I should know this. I've mentored many students. Interns. Sparsgard, you have interns at your work that you manage specifically yourself? It's quite it's a responsibility. So what I'm trying to do is create a submit transfer lookup, and I want this transfer to succeed because a successful lookup returns no results. So this is like the thing that we want to run. All right, so I think this will get us there. Let's try this. You can tell that I'm starting to lose focus. I mean, I'm continuing to lose focus. It's 2.5 hours into the stream, and 2 hours is about the point where things start falling apart. All right, so we made some kind of error here, and this doesn't type check anymore. Okay, so there's our stuff, and let's go back through and see if we can get our pointers. So here's our first request. This was a successful request that did have results, and it has a result pointer. This was our second request, not get account transfers. This was result pointer. That was also a successful pointer. This had no results though, but it is a valid pointer. So the Tiger Beetle client here presumably sent us a valid pointer and told us the pointer length was 0. And I want to make sure that's true. No, this might not be true. This is our lookup here. Yeah, I want to do a different lookup here. Instead of looking up all these accounts, I want to look up just one account, because in a lookup, a success has no result. So here we want to look up something that definitely exists. This should be no results, basically. Let's try this one more time. So here we did, okay, so we found one, but this found is an empty result. And again, though, we can see that Tiger Beetle gave us a pointer, but there was no length to this pointer. And let's confirm that. Let's go add logging for length here in our library Let's see, here's pointer. Let's also add pointer len. So what seems to be happening is that on a successful query, even if there are no results, TB client will give you a valid result pointer. But if the query was completely unsuccessful, it's going to pass you a null pointer, which is why we're seeing this bug in our unsafe code. And this is result len. Student workers and interns are distinct in Denmark, huh? Oh, interns are unpaid. Gotcha. What do you do, Sparsgard? You've mentioned a few things, but I feel like we're getting to know each other now. So you're in Denmark and you have student workers who are employed, whereas interns are unpaid. In previous jobs, I've dealt with paid interns, and I've mentored paid interns, and I always felt very guilty about mentoring them poorly. But some of them are very brilliant and successful. Site reliability engineering. I don't know if I think I know what site reliability engineering basically is. Sorry, I'm getting distracted, Sparsgard. We're gonna have to wrap this up soon. I am toast. Okay. So right now we're printing the pointer length here, just kind of interrogating the behavior of TB client. So again, let's look at our transfers or our request. Here's our first request. This was a successful request with data, and you can see it gave us a pointer, a valid pointer, and a non-zero length. Our next request, we did get a valid pointer, and our pointer does have a length, which I'm surprised at because I thought this should be an empty result. But apparently it was not an empty result. Here's our failing case right now. We're getting a 0 pointer and a 0 length. But I'm very curious why this pointer had data in it. I'm going to keep yak shaving here a bit. No, this is so bad. So bad. So our query here in main that we thought was going to succeed with no data was submit transfer lookup. So we're looking up ID 1, and in submit transfer lookup, when we collect results, I was definitely wrong. Okay, so again, I was wrong. A successful lookup does have data. An unsuccessful lookup does not have data. And that makes sense if you think about it, but I'm not going to think about it. So here I'm going to put a bad ID. So this should be unsuccessful, and this should have an empty result. Let's try this test one more time. Okay, now this is interesting. This is very interesting. So here's that case. This was a successful result, but no data. And Tiger Beetle did pass us some kind of sentinel pointer, which got past Rust's. Oh, this is very interesting. Oh, that's very interesting. So Tiger Beetle, in this case, it passed us a value. This is not a valid pointer. I mean, it's a valid value for a pointer, but it's not pointing to anything, obviously, because it's a sentinel value. And we constructed a slice out of this. So I think this is undefined. This has got to be undefined behavior. Maybe not. We did construct a slice out of this pointer, but probably we should not construct a slice out of this pointer. Because that is a very weird pointer value. But then in this case that we're looking at here, we do have a bug. So when TB client returned us an error, it gave us a 0 pointer, not this sentinel pointer, which seems a little strange. I mean, maybe the whole point here was to allow safe languages to construct a slice out of this safely. and here to not be able to construct a slice out of this. But this is all like question mark inducing to me. I don't want to be dealing with this pointer at all. So what we're going to do, Rastafari, yeah, you can see that 0 pointer. So this is all very interesting stuff. So this is completely valid. This is interestingly valid. This is non-zero pointer with a 0 length. When we construct a slice out of this, it's a very weird slice, and I'm not sure whether that's a valid Rust slice or not. And then this is totally an invalid Rust slice, and the Rust library tells us like this is not a valid pointer to put into your slice. So what we want to do to fix this is just we're going to look for that pointer length 0 in this callback, and we're just going to avoid touching this pointer if pointer length is 0. Yeah, I'll drop my GitHub into chat right now. I'm Burson on GitHub. GitHub.com/Burson or burson.github.io. It's got succinct information about me. Yeah, Rastafari is asking what that weird looking pointer signifies and whether it signifies uninitialized memory or not. And I'm very curious what the origin, what the provenance of this pointer is, whether the TB client library just picked this as some kind of sentinel value, or whether maybe it came from the underlying Zig allocator. Like maybe when you create a 0 length Zig slice, Zig puts this sentinel value into it. I'm not going to dig into it right now. Like I said, I'm pretty toast, and I just got to get across the finish line here. But a lot of interesting programming questions raised by what we're seeing here. All right, and again, if we go to from raw slice or from raw parts, here is where our bug is. We're not handling this null pointer correctly. And we've done this pattern elsewhere. Right here, same situation where this pointer was not a valid pointer. Ah, interesting. Okay, gosh, I hate to keep yak shaving here. So we had a question earlier about why we tripped this error previously, but not this error. This error kept getting through. And this is when we're kind of reinterpreting this raw pointer as a slice of bytes. And this is where we're reinterpreting this raw pointer as a slice of some specific type with an alignment. And in this case, this slice from raw parts will check several things, but one other thing is whether the pointer is aligned properly for the type you're trying to create a slice from. So here I'm trying to create a C result, which is a generic type that could be multiple types with multiple alignments. And our sentinel value, you'll remember, was something like 0xAAAA. And bytes are properly aligned for any pointer value. But some arbitrary struct type is not properly aligned for any arbitrary pointer value. So this tripped before because this weird looking sentinel pointer was not properly aligned for whatever type we happen to be casting to. That's how we saw this error once, but it slipped through over here. And so the way we saw this before was we just checked whether this pointer was empty. The slice was empty. And this is checking the length of the slice, right? So if the length was 0 or was not 0, we created a normal slice. If the length was non-zero, if the length was 0, then we constructed an empty slice in the normal safe way. And this pattern, I'm wondering if there is some standard helper method in the standard library I haven't been able to find, but this seems like this is such a huge footgun for unsafe code. I mean, it's nice that From Raw Parts is able to catch it usually, but pretty nasty stuff. And I've never actually had to write exactly this code in Rust before. I learned this while doing this project. But anyway, this result will just follow this exact same pattern. So we'll say if result len does not equal 0, then we will unsafely construct a slice. Otherwise, we'll just make an empty slice. And let's run this code and see if it doesn't crash. It does crash. What did we do wrong? Oh, this is just a panic that we inserted at some point for some purpose. Let's go back to our, and this print line we can get rid of. Not using that anymore. And somewhere there's a to-do in here probably. Yeah. So we still haven't fully evaluated, we still haven't fully implemented this method. Because remember, this method we have already confirmed, pretty much what we've been doing for the last 2 hours is confirming our suspicion that get account transfers does not support multiple events. And we have done that now. We have confirmed that this should just be one account filter. So some types of Tiger Beetle requests support multiple events at a time. Some type of Tiger Beetle requests, namely range queries, it seems, only support one event at a time. And the kind of pattern here we've developed for requests, implementing more requests, assumes multiple events at a time. So we have to do a little bit more to support the case where there's only one input type and the output has multiple results for one input. And that's going to require a little bit of new thinking and new coding. And at the moment, my brain is not well equipped for new thinking and new coding. So let's just get this to type check again, cargo check, and do a little checkpoint commit here. And let's wrap this up, chat. So this was a pretty good stream. I thought it was going to be very boring, just kind of repeating patterns we had established before. And we managed to implement one new query based on our existing understanding. That was a point query. But then when we discovered the next query was a range query, we learned a little bit about how range queries are handled in Tiger Beetle and that our existing patterns that we had built up for implementing point queries is not quite sufficient. And then we spent quite a while debugging why our query account transfers was not returning results. And it turned out we hadn't set up the flags in the correct way, the flags to the query. And then we did some debugging to figure out whether or not this particular range query supported multiple events as input at a time. And we confirmed our suspicion that this range query does not support multiple events at once. And then finally, while doing that exploration, we found an unsafe bug where we were unsafely constructing a Rust slice from a 0 pointer. And so we debugged that a little and we fixed that bug. So this was a very productive stream. And I appreciate everybody who came and chatted and helped me out. And it was really great. And I especially appreciate people who've come back multiple times. This has been a very good stream, and I'm grateful for all the support. My name is Brian Burson, BRSON on GitHub, github.burson.io. It's got some of my socials and other information. I'm doing this stream frequently, like several times a week, but irregularly, not on a fixed schedule yet. But I always send out like a notification 10 minutes ahead of time on the Tiger Beetle Slack and on my Mastodon before I get on stream. And this will all be uploaded to a playlist on YouTube eventually as well. So I'll see you all next time. Thanks for everything. It's been great. See ya.